Okay, well, good morning, afternoon, wherever you are, whatever time of day it is. First of all, I thought the test went relatively well. Logistically, everybody got everything turned in. I did have several people suggest that I have you guys submit it through Canvas, so I'm sure we will do that next time. So for the final exam, we'll submit through Canvas. We can talk more about that as it gets closer. So we're going to jump right in here to the next chapter. This is going to be notes for section 6.1. I'm going to do these notes on the video, obviously, like I'm doing now, and then I'll go through them in class on Tuesday evening, um, just to make sure that everybody gets everything and there's nothing missing. Basically, this is just going to be using our factoring a lot. So we're going to talk about rational expressions. So to talk about rational expressions, we need to talk about ratios and rational numbers. So this is going to be just a quick review of ratios and rational numbers. So a ratio is a comparison of two numbers. Usually it's written as a fraction, and the bottom cannot be equal to zero. Okay? A rational number is a ratio written where it's an integer to an integer. And all that means is those top and bottom, they can't be decimals. Um, so bottom also still can't be equal to zero. So for examples, 3/4, that's an integer to an integer. 0.6 repeating. Well, 0.6 repeating can be written 2/3. 0.25 can be written 1/4. Some examples that would not be rational, numbers that cannot be written as a fraction, would be square root of 3, square root of 5, pi, things like that. Those decimals would all go on for forever. They cannot be written as integer to integer. Okay? So a rational expression is a ratio polynomial to polynomial. Okay, so the top's a polynomial and the bottom's a polynomial. And once again, the denominator cannot be equal to zero. I'll talk more about that in just a second, okay? All right, so to reduce a rational expression to lowest terms, what we're gonna do is factor top, we're gonna factor the bottom, so obviously our factoring comes in, and then we're gonna cancel any factors, that's important, in common. Anything they have on the top and the bottom, we're going to cancel it. They have to be factors. So for example, I'm going to make a really easy one, 6/8. I'm going to factor the top, 2 times 3. So I broke 6 up into its factors. And the factor the bottom, 2 times 2 times 2. Now I'm going to cancel anything they have in common. So there's a 2 on top and a 2 on bottom. So my answer is 3/4. Okay, so right here, I'm saying you have 6 plus 3 over 6, or excuse me, over 8 plus 3. My question for you is, can you cancel the 3's? Can you cancel the 3's? The answer is no. They are not factors. Okay, so the answer here is you have to do the top, which is 9, and the bottom, which is 11. You can't cancel those 3's. If you do, you'll get the wrong answer. It's just incorrect. You can't do it. Only thing that can cancel are factors. Okay, so here's, I don't know, 3 or 4 or 5 examples. Okay, so you got a polynomial over a polynomial. You cannot cancel those x squareds. They're not factors. It's because of this subtraction on the bottom and the subtraction on the top. So what we have to do is factor the top. And if it's factorable, it's not, which it's not, you can't factor the bottom. So the top is going to factor into x plus 3, x minus 3. Now I'm going to cancel any factors they have in common. So this is a factor, and this is a factor. So I'm going to cancel those factors. All right, so then my answer is x plus 3. I meant to say a minute ago, up here, if this problem had been written 6 times 3 over 8 times 3, now you can, since this is multiplication, you can cancel those. And your answer is 6 over 8, which we just said reduces to 3 over 4. Okay, so these 3's do cancel because they're factors. These 3's do not cancel because they're not factors. Only thing that cancels are factors. So that's why we're turning everything into factors. Okay, so here I'm going to factor the top. I'm going to factor the bottom. The bottom's easy. That's a difference of perfect squares. So that's y plus 1, y minus 1. This one is going to be y and y, and I need factors of negative 6 that add up to be negative 5. That's going to be negative 6 and positive 1. So minus 6 plus 1. So my factors that cancel are the y plus 1s. So my answer is y minus 6 over y minus 1. And these y's are not factors, so they do not cancel. Okay, moving right along. So here I'm going to factor out a 2. It gives me a cubed minus 8. And I notice that is a difference of cubes. I'm going to factor out a 4, and that gives me a squared minus 3a 2. Okay, so now the 2 and the 4 now are factors. So I can cancel. That becomes 1 and 2. Okay, so now I'm going to factor this a cubed minus 8. It's going to be a minus 2 and a squared plus 2a plus 4. That's how I factor a difference of cubes. And then this trinomial, I'm going to factor. And I need factors of negative 2 that add up to be negative 3. That'd be negative 2 and negative 1. So then the factors that cancel are the a minus 2's. So my final answer is a squared plus 2a plus 4 over a minus 1. Oh yeah, I forgot about that 2. The 2 just kind of comes along for the ride. And you can distribute that 2 if you want. You could call the bottom 2a minus 2 if you want, but usually we just leave it. Okay, and this last one here, I'm going to factor by grouping, top and bottom. Okay, so the top, I'm going to factor out an x, that gives me x minus 3. And I'm going to factor out an a, that gives me x minus 3. And down here, I'm going to factor out that x minus 3. Still on the top, that leaves me with x plus a. And on bottom, I'm going to factor out an x, that gives me x minus a. I'm going to factor out a negative 3, and that gives me an x minus a. That goes and that goes. So now I have an x minus a over x minus 3. X minus 3's cancel. And I should keep up my color scheme here. So minus 3's cancel. So now I'm left with an answer of x plus a over x minus a. Those x's cannot cancel because they're not factors, and the a's cannot cancel because they're not factors. So one thing I need to do is back up to about right here, and let's talk about the denominators. So if you look at this original problem, that denominator is x minus 3. That means x cannot be 3. Because if x is 3, that's going to cause this denominator to be 0, which makes this whole thing undefined. In this one, you got to look at the original problem. So x can't be negative 1 and x can't be positive 1. Positive or negative 1. Because if x is negative 1, right here, I know it factored out, or you could look right here. Negative 1 squared is 1. 1 minus 1 is 0. It cannot be positive 1 either, because 1 squared is 1. 1 minus 1 is 0. So 1 and negative 1 both cause the denominator to be 0. Just like up here, 3 caused the denominator to be 0. So you have to eliminate them from your answers. So right here, a can't be 2, and a can't be 1. Okay, so here's my answer, and here's what we call our restrictions on the denominator. And here, I'm going to say x can't be 3 because of this part right here. And I'm going to say x can't be equal to a, because right here, if x and a are equal to each other, x minus a would be 0. That's a pretty tricky one. So we'll talk more about that when we're in class. Okay? So that's an example, or several examples, of simplifying rational expressions. And the way we did that is by factoring the top, factoring the bottom, cancel whatever factors they have in common. Okay, and then I went back and I talked about the restrictions on the denominator. Okay, well, I will see everybody either at office hours at 4:45 on Tuesday or in class at 6 o'clock on Tuesday. Okay, everybody be well and be safe. Bye-bye.